In the next 3 videos, I will show you how a video call system can be created with WebRTC in JavaScript. I have tried to keep this course detailed enough and it is like an hour long, but once you complete this course, you will know how to use WebRTC for creating video call integrated systems. Now before you go into this course, it is highly recommended that you watch my other video that explains how WebRTC works, and it also tells you about the WebRTC terms like SDPs, turn servers, IC candidates and stuff like those. And these terms are required for you to know before you can understand the content of this course. So watch that video, I will have it linked in the description, and the code for this course can be found in a Github repository. I will have it linked in the description too. You can refer to it if you don't want to code while watching the video. And now before we start writing any code, it will be good to get to know with the user interface and the entire system that we are going to create. So let's take a look at that and then we will dive into the coding part. We are going to have 2 user interfaces. I'm keeping 2 separate user interfaces just to create contrast between 2 main parts of WebRTC, that is creating offer and then creating answer in response to that offer. And it is easier to understand when these things are done separately. Create offer, I have this interface here where I can put in the username, and when I click on the send button, then the username is sent to the server and the server stores this username. And after that I can click on the start call button. And when I click on the start call button, then the sender will create its offer and then it will send it to the server, and then the server will store that offer against the username that was previously sent. And once the offer is sent, the sender will start generating its ICE candidates, and then the candidates will also be sent onto the server, and then the server will store that thing. And now I am going to click on allow to give permission to these things. The sender is waiting for someone to join the call. So for that we are going to use the other interface that is called the receiver. And here I can put in the name of the person who I want to call. And then when I click on the join call button, then it will ask the server for the offer and the ICE candidates of the username that it sent. And when the receiver gets the offer and the ICE candidates from the server, then it creates its own answers in response to the offer, and it sends the answer to the server, and then the server sends the answer back to the username that it tried to call. And in the same way, after the answer is sent, the ICE candidates are gathered by the receiver, and then the ICE candidates are too sent to the server, and then the server sends it to the username that it tried to call. And when I click on allow, then you can see there is an echo, and that is because the sender and the receiver is running on the same device. So I am just going to click on the mute audio button in both the sender and the receiver, and we have that thing off. And when I click on the mute video button, then the video gets muted, and when I switch to the receiver, then I shouldn't see this video. And when I enable it again, then I can see the video. Okay, now we can go ahead and write the code that will perform this logic. I'm going to create a separate folder for this tutorial, and I will name this WebRTC tutorial. And now I'm gonna open VS Code. You can go ahead with any code editor, it does not matter. And then open this folder in your code editor. Inside the root folder, create another folder and name this sender. Since our application is going to have 2 parts, one will be the sender who will initiate the call, and one will be the receiver. The receiver will be joining an already initiated call. So create another folder into the root directory, and this will hold all the HTML, CSS and JavaScript files of the receiver. First I will design the sender and write all the logic for the sender, and then I will write the receiver's code. After that I will create a node server, a node socket server that will connect the sender and the receiver. So inside the sender folder, create an HTML file. I'm going to name this file sender.html. I will copy paste the boilerplate code since I believe that all of you know HTML. Inside the sender folder, create a JavaScript file. I am going to name this file sender.js. And we will also need a little bit of CSS, but the CSS file will be common to both sender and the receiver. So in the project folder, create another file and name this file style.css. And let me just include these two files in the HTML. I am also going to open this sender.html file in a Chrome window, and I'll put it next to this VS Code so you can see all the changes that will be happening in the sender.html file while we write it. Okay, so the first thing that we want here is an input box that will take the username of the sender and it will put it on the node server, and then the receiver can use that username to call the sender. So create a div, and this div is going to hold an input element. I'm going to give this input element a placeholder which will say enter username, and this input will be of type text, and also give this an ID so that we can refer to it in the JavaScript code. I'm going to call it username input. And then I want to start a new line, and from the new line I will have two buttons. The first one will be called send, and as the name suggests, when this button is clicked, we will send the username to the server and the server will store this username. And then we will have another button which will be called start call. And when this button is clicked, then we will create our offer, and then we will send that offer to the server, and the server will store that offer against the username that was previously stored. And we will also need a few functions that will handle all these functionalities when these buttons are clicked. So when the send button is clicked, then I'm going to call a function which will be named send username. And when the start call button is clicked, then I am going to call a function which is named start call. And none of these functions have been created yet. We will write them in the sender.js file. And now if I refresh this Chrome tab, then I should see all these elements here. Okay, so these many elements are enough to start a call and connect to the server and stuff like that. But we will also need elements that will show the videos. And for that, I'm going to create another div. And I will also give this div an ID so that we can refer to it in the sender.js file. So initially this div will be displayed to none. But in the code, once the start call button is clicked, we will show this div. And this div is going to hold the video elements. So the ID that I'm going to give this is video call div, and this div is going to hold two video elements. The first video element will be to show the local video, and we will also add the attribute autoplay. So once the video is available, once the stream is available to this video element, it automatically starts playing. And now we will need another video element which will show the video of the remote user. This will also have the autoplay attribute. And this video call div is going to hold two buttons. One button will be to turn off the video of the local user, and the other button will be to mute the audio of the user. And I'm going to put those elements in another div which will be placed inside the video call div. And I'm going to give this div a class name, call action div. Not very good with the names, but it will work. Now add the first button, and the text on this button will be mute video. And when this button is clicked, then we will have to call a function, and this function will be named mute video. We are going to create these functions in the JavaScript file, so don't worry about that. And then add another button which is once clicked, call the mute audio function, and the text on this button will be mute audio. Now if I refresh the Chrome tab here, then this will all look very messy. So we will also have to write some style.css to position these elements. Okay, so first select the video call div. And this div will have position absolute and it will be placed at the top left corner. So top 0 and left 0. Width and height of this will be 100%. And the display of this div will be set to none because we only want to show this div once the start call button is clicked. But for now, I'm just going to put it block so that we can see it in action once we refresh this HTML page and before we actually write anything in the sender.js file. So temporarily leave this to display block, but later we will change it to none. And then I am going to select the local video element. The position of this element will also be absolute. Top will be 0 and left will be 0. We will also give this a margin of 16 pixels. We will also give this a border radius because it makes it look, cool. And then the width and height of this video element will be 20%. I hope you all know these CSS properties. Since this is not a CSS video, I'm not going to explain all these. And then we will also give this a background sharp FFF, which is white. And now I'm going to select the remote video. The background of this will be black. And then width and height will be 100%. And let's try refreshing this page. And we have the thing ready. But the mute audio and mute video buttons are missing. And we are going to place them right over here. So select the call action div. Remember, this is the div which is holding the mute audio and mute video button, and it is inside the video call div. And the position of this is also going to be absolute. And from the left side, it will be placed 45% away. And from bottom, it will be 32 pixels away. Now let's try and refresh this page and you should see your buttons. I want to do one more thing to the CSS of these buttons. Since these buttons are clickables, I don't like it when the cursor is not pointer, when the cursor is actually hovering on the buttons. So I will select all the button elements and I will set the cursor to pointer. It is not necessary, I just find it very annoying, so I will just do that. And if I go there, then I should see the pointer cursor. Okay, so now we can go ahead and write all the logic in the sender.js file. But before that, set the display of the video call div to none. And this is the final interface that you should see here. And now let's write the logic that is going to control all these UI elements. So open the sender.js file. The first thing that we need is a WebSocket object. If you haven't worked with WebSockets before, then don't worry, this is not a very complex topic. By the end of this tutorial, you will be able to know what WebSockets do. But for the time being, just know that WebSockets allow full duplex communication, meaning once a client and server connection is established, the client and the server can send data back and forth continuously without having the client to make any further connection request. And here we need to pass a string which will be the URL of the server, of the socket server. But we haven't created the server, so for now just let it be empty, and we will come back to this once we have the server coded. And the next thing that we have to do is send the username to the socket server, and the server will store that username. When the send button is clicked, then we are calling a function named send username. So let's create that function. Here the first thing that we have to do is get the username from the input box. And I want to store the username in a global object. So create a global username variable. And the ID of the username input is username input. So just copy that. And then the username will be equals to document get element by ID, pass the ID and the value of this. And now we can send the username onto the socket server. And for sending any kind of data, I am going to use a separate function which will be named send data. And this function will accept an object, and this object will have a type. And here I am just going to pass the type store user. So on the server we know what we have to do with the data. So if the type is store user, it means that we have to store the username. If the type is store offer, then we have to store the offer. And if the type is store candidate, then we have to store the ICE candidates. And I'm not going to pass the username to this object here. Instead, I will just create this send data function first. And in this function, I'm going to attach the username. Because every time we have to send any data, we need to send the username also. So the server knows who the data belongs to. And then we can send this object to the server by calling WebSocket send. And this requires a string data as the parameter. So we are going to use json.stringify to convert our data object to a string. And the next thing that we have to do is manage the start call function. We have a start call function that we need to create. And in this function, the first thing that I want to do is set the display property of video call div to inline, so it is visible. I'm gonna get the video call div by its ID and set the display of this to inline. And now we will need a video stream from the device, and we will have to show that video stream in the local video object. To get a video stream, we have to call the navigator.getUserMedia function. And here we have to pass a constraints object defining what kind of a stream that we really want. To keep it simple, we can just include a video and set it to true. And then we can add audio and set this to true. But we also have options to provide specific details of what kind of stream do we want, like the minimum width, minimum height, frame rate, and all those kind of stuff. And to specify all those things, instead of passing true, we will have to pass an object instead. And in this object, we can specify the frame rate. Let's just keep it to 24. And then we can specify the width. Again, the width can be either a direct number or an object. And why will we need an object here? To specify a minimum width. So we can let it go down to 480. And then we can also specify the ideal width. Let's set it to 720. And then we can also have a max property. Let's set it to 1280. And we can do similar things to the height as well. But I am not going to do it for the height. Instead, I will just define an aspect ratio. And I am going to keep it to 1.333, which is almost near to 4:3. And 4:3 is good for laptop and computers. I will put a link to a web page in the description where you can see what kind of other constraints that you can give to specify the type of audio or the video stream that you want. And the getUserMedia function receives a callback function as the second parameter, and with this it returns the stream. So here the first thing that I want to do is show this stream in the local video element. And the ID of the local video is local video. So let's just get that element by its ID. Document.getElementById local video .src object is equals to stream. By the way, we will need this stream object outside of this function too, so we will have it stored globally. I'm going to create a global local stream object, and this will be equals to the stream, and here I'm just going to pass the local stream. And the get user media function also accepts a third parameter, which is an error callback. So if any error occurs, if it fails to get the user media, then this function will be called, and here we will just log out the error. If you refresh this Chrome tab, then your app will not work after you start the call or click on the send button, because when we are passing an empty URL here, then the next lines do not get executed and the program exits from this line. So temporarily I'm just going to pass a dummy URL that will go to the local host and some random port number. And let's now refresh this page, enter some username. It does not matter because we are not sending it anywhere. The socket is closed as this address is invalid. But if we click on start call, then you can see the get user media function automatically handles the permission. I'm just going to click on allow, and you can see there is some weird audio coming out from the device. So I'll just stop speaking and I'll close this. Now if you noticed, the video did not cover the entire local video element. There were some white areas around it. So to fix that, what you can do is go to style.css, and in the local video, instead of setting width and height to 20%, we can set max width and max height to 20%. What this will do is, if the local video's width reaches 20%, then it will adjust the height accordingly to fill up the video. So if I refresh this page now and click on start call, allow the permission, then I will be able to see only the thing that is required and not the white background behind it and the ouch. Okay, fine now. Now just go back to sender.js. We have our user media ready, we have the stream ready. Now what we have to do is we have to create a peer connection, and then to that peer connection we will just attach this local stream, and when someone connects, some other peer connects to our peer, then this stream will be available to that person through a simple function that is available in the WebRTC API. So create a global variable named peer connection or peercon, and this will be equals to new RTC peer connection. Here we have to pass some configurations like the stun servers and the turn servers that it is going to use to generate the ICE candidates and to connect to the peer. So I'm just going to create another object which will be named configuration, and this will have an ICE servers object, which is by the way an array. And here we can pass two objects. The first one will be the URLs or the links of the stun server, and the second object will be the URL or the links of the stun server. So how will you know which stun server to use? Well, there are many public stun servers available. There is this GitHub page which contains many of the public stun and turn servers which are available, but not all of them are usable. So to test which one to use and which one is going to work, what you need to do is, there is this another website which is Trickle ICE. I will put a link to this in the description. And to find out if the stun or the turn servers actually work, what you need to do is just copy the URL of the stun server and then just first remove that. So select that and remove server, and then just paste the link over here. This is not complete. We will also have to pass stun stun colon at the beginning of the link, and then click on add server. After this, click on gather candidates, and if the type of the candidate returned has srflx, then this server can be used. And for the turn server, you need to see relay in the type. Otherwise the stun server is no good. Now go back to the code editor, and inside the ICE servers array create another object, and this object is going to have a URLs property. And remember, we can have a single server or multiple servers. And multiple servers are suggested to use because if you have multiple servers, then one of them is going to return better candidates that you can use to connect. And I have not been able to find any good turn servers, so I'm just not going to use them for this tutorial. But you can find out some good public turn servers or some good private turn servers, and you can use them in the real applications. But for now, if we are using multiple stun servers, then our WebRTC connectivity will happen most of the times. So in this, I'm going to pass an array of URLs, which are the first 3 URLs that you can find here. And I'll just paste them here. And now we can pass this configuration object in this RTC peer connection. And then we can attach our stream to this peer connection by calling peercon.addStream, and then add the local stream here. And when this peer connection connects with the other guy, then a callback function will be called, which is onAddStream. And this one is going to have a parameter. I'm just going to call that E. And then I can extract the remote stream by calling e.stream. But I have to show the stream in the remote video element in this one. So I will just get that element by its ID, remote video, and I will set the source object to e.stream. And after this, what we can do is we can create and send our offer, and this offer will be stored on the socket server, and when someone tries to connect with us, then the server will send our offer to that person and then get that person's answer and then return us that answer. And then we will store our answer in the peer connection. We will create the offer and send the offer in a different function. So let's just create that create and send offer function. And to create the offer, we just have to call peer connection dot create offer. This will return us a promise, and we are going to call that offer. And now we can send this offer onto the server by calling send data. Type will be store offer, and along with the type, I will also attach the offer. And after creating the offer, we also have to set the description of the remote peer connection. And that is simply going to be peer connection dot set local description offer. After this, we can also pass a second parameter for any error callbacks. And if any error occurs while creating the offer, then we will log out that error. And one more thing, as soon as the offer gets created, the peer connection also starts gathering the ICE candidates, and those candidates need to be sent to the server, and then the server will send that candidate to the person who is trying to connect to us, and using the candidate we can make the connection happen. And when we have a new candidate created for the peer connection, then we get the onICE candidate function called, and this will have an event which I'm just going to call E. We'll check if the candidate in this event is null or not. If it is, then we will just simply return from this method, and we will not send this candidate to the server. And remember, this onICE candidate is called multiple times. Every time there is a new ICE candidate, then this callback function is called, and we need to give all of those candidates to the other guy who is trying to connect with us. And now we can send this candidate to the server by calling the send data function, and the type will be store candidate, and we will also attach the candidate here. Okay, so we have sent our offer and our candidates to the other client. And now when the other client sends their offer and their ICE candidates to us, then we have to accept that and we have to give it to the peer connection so that the connection is established. Whenever there is any message from the server to the WebSocket, then the onMessage function is called. And in this event, we have event.data. This is going to be a string to handle all those signaling data, getting of the answers and getting of the candidates. I'm going to do that in a separate function that will be called handle signaling data. And I'm just going to get the object from the event data and pass it to this function. Now let's create that function, handle signaling data. Inside this function, I'm going to switch the type of the data, and if the type is answer, then I am going to set the description of the remote user on the peer connection, and I'm going to get the answer from the data and pass it to this function. And then I will break out from this case, and then I'll check if the type is candidate. And if the type is candidate, then I will add that into this peer connection with the help of peercon.addICE function. And I'm just going to pass the candidate from the data. Okay, so I think we are pretty much done with the sender, and in the next video we can start doing things with the receiver part. And finally, in the last video, we will write the server which will connect the sender and the receiver. Till then, bye bye, get ready, drink some coffee, and then just come back again.